Welcome back. In the previous video, I gave you an introduction on what is stereochemistry and what makes a carbon a stereoisomer that's an R or S. You need chirality. And what is chirality? A carbon must have 4 different groups attached to it, and that's what makes it chirality, right? But we didn't actually determine what is R or S. We only established what's chirality and what is not, okay? Because that's all I did. So here we're going to learn some basic rules, and I'm going to keep all of this to just this one video, okay? So you're not going through 10 different videos to really understand R and S. It's just going to be one video, so if it's 10 minutes long, just bear with me, okay? What are the rules? First, determine if each carbon in a molecule is chiral, okay? We're going to do some examples. But first, determine if a molecule may contain 10 carbons. Determine which ones are chiral. Okay? If a carbon is not chiral, then that carbon cannot be R or S. A neighboring carbon can be, but that carbon is not. Okay, so your first job is to determine if each carbon in a molecule is chiral. Assign priority, again, first point of contact. With respect to the carbon, higher the atomic number, higher the priority. So this idea of first point of contact is exactly the same as how I have taught you when we learned about functional groups or other things that we have done, okay? I've taught you about the high priority. Even when we learned Z and E or cis and trans, I had taught you about the first point of contact. That idea of first point of contact is the same. If a first point of contact is the same, then look further. Bigger the group, the higher the priority. Okay? Again, all of this will only make sense when we actually do a problem. Okay? So first rule is determine if each carbon in a molecule is chiral. Second, assign priority. With respect to that carbon you're assigning priority to what? 4 groups that are attached to that carbon. Okay? You're not just assigning priority anywhere you want. You have a carbon that you're trying to determine if it's R and S. If that carbon you deemed as chiral, then there's 4 groups attached to it. Those 4 groups is what you're assigning priority to. Okay, let's get that out of the way, because you don't just go as assign priority to anything you want in the molecule. Use the table below to determine if the carbon has R or S configuration. I will provide this table to you. And I'd like to thank at this moment James from Mastering Organic Chemistry, because I think he created this table, and I'll explain how to use this table. So many thank you, James, for the table. And I think James got a lot of interesting content on Mastering Organic Chemistry. That's his website. You can Google it, and that'll usually be the first website that comes up. So you can look up James for additional help if you are interested. In some cases, a minor modification is needed before you apply ABC. And I'll explain that as well with a case example. Okay, it's called a single swap rule. Okay, so these are the rules. So ABC is primarily the rule. In some cases, you would have to do some modification before, or you can do rule A and then you have to do a modification and then do rule B and C. It doesn't matter. So that's why I kept it as minor modification, then rules A and C. All right, here's a molecule. Now I'm going to put this table up here. Okay, how do we use this table? Well, there's 2 columns, 3 columns. Position of the 4th rank substituent. And what I mean by back here, I'm going to put all the molecules. Actually, let me put this up. Remember I said that this is in, right? And I said this is out, right? Well, in is same as front. Out is same as back. Let's get that out of the way. And as I said, once you deem a carbon is chiral, then you assign priority. You always want your lowest priority group, which is usually hydrogen, Okay, it's the lowest priority there is in the periodic table. You want it either in the back or front position. Usually most of the time I will give the hydrogen either in the front or back position. And once you assign priorities, you determine with respect to the 4 whether the arrow that we are going to do is clockwise or counterclockwise, and then we can determine if it's R or S. Okay, now without a polarimeter, we have to come up with alternate ways of determining R and S. So let's go to this. This is, if I just quickly draw this, if you think about it, this is methyl, right? CH3, CH. Again, I will not use this to, this is the first time we're doing this, so I'm writing it this way, but I would not consistently be doing this same way because it takes time and it beats the purpose of a line structure, right? But the first time I'm doing it because this carbon is attached to, right? Sorry, this is not attached to a hydrogen here, right? So this is attached to a hydrogen, a Br, and this whole thing, and then a CH3, right? Is this carbon chiral? No, because this carbon contains 3 hydrogen. Each carbon must contain 4 different groups, right? So this is not chiral. Is this chiral? Yes, it's got hydrogen, a Br, a methyl group on one side, and this big group on the other side. That's the way we see it. This is a one giant group. So this is chiral. Let's put a star. Is this chiral? No, it's containing 2 hydrogens attached to it. Even though these 2 groups are different, this group is not. These 2 groups are, yeah, they're different, but this is the same, so this is not chiral. Moving on to this carbon. This carbon contains a Cl, hydrogen, a methyl, and this whole group on the side. This is giant, right? So this is chiral. So we only have 2 chiral carbons, right? So how many stereoisomers possible? Well, that depends on how many chiral carbons. So it's 2 power n, which is 2 to the 2, which is 4. Okay, that's that. Now let's assign R and S. So let's go to this structure. This is the carbon. The first point of contact is, this is carbon and this is carbon and a hydrogen and a Br. This carbon is attached to a methyl and a carbon and a C. This is attached to 2 hydrogens, but this is attached to this whole thing, right? This is only attached to 3 hydrogens. This is not only attached to a hydrogen, but it's attached to this whole big group. But first point of contact in that context, this will be 1, right? Because CBr has the highest atomic number. Hydrogen is the smallest. We already established that. So that's 4. Between these 2, they both have carbon. So the first point of contact is the same. So we looked further, and this is a methyl, and this whole thing is CH2, and then it's also attached to this. So this will be 2. So this will be 3 then, right? So now connect the 1, 2s, and 3s. So 1, 2, and 3. That's the arrow, direction of the arrow. That's clockwise, right? Clockwise. And where is the lowest function? The 4th group is in the back position, right? 4, that's what this means. 4th substituent is in the back position, right? Which is what this means. So clockwise back, what is clockwise back? Is R. So this is R. Okay? And then let's do it for this one. This is 1. That's the first point of contact. This is 4. Between these 2, again, this is CH2 and this is attached to the whole thing. So this is, sorry, this is 2 and this is 3 because that's methyl. Now we connect the 1, 2s, and 3s. That becomes a counterclockwise, and H is still in the back position. The lowest priority is in the back. Counterclockwise back is S. So this carbon is R and that is S. We always write left to right, okay? That's what left to right. So let's try this example here. I'm going to, again, let's redraw this here because it was overlapping. Again, I'm not going to every time expand the line structure because in lieu of time. Now, carbon with the double bond can never be chiral, so you can automatically rule it out. And this is again CH3, so this is not chiral, that's not chiral. This is oxygen, so we don't even talk about chirality. This is a CH2, so that's not chiral, this is not chiral. So we have a total of 1, 2, 3, 4, 5 carbons, of which 4 are not chiral, right? 4 not chiral, because they have at least more than one identical group. That means there's only one chiral because this carbon now is attached to a Br, a hydrogen, and something on this side and something on this side. I'm calling something because it's just a giant group with respect to the carbon. But the first point of contact here is C is attached to a Br, so that's 1. We've already established hydrogens 4. This carbon is attached to a carbon. This is attached to a O. The first point of contact, O, is bigger. So this is 2, this is 3. Now connect the 1, 2, 3. You can only connect it in a counterclockwise manner. So CCW, and the 4th ranked substituent is in the back position. So counterclockwise back is S. Because there's only one carbon. How many stereoisomers possible for this? Where there's only one chiral carbon, so 2 to the n is 2 to the 1, which is only 2 possibilities. Okay, let's actually do this one because this is easy. This is easier. Why did I choose this one? Because if you take professional exams, they don't always tell you what the back group is. They usually give you the front or the back or the in or the out. If this is OH, by default, the back will be hydrogen. Here I've given you the front or the in, the back or the out, you have to draw it yourself, and that's usually hydrogen. Now, this is the compound has 1, 2, 3, 4, 5 carbons, of which this is not chiral because it contains 3 hydrogens, this is 2. You have to have 4 different groups, so that means there's only one chiral carbon, so 2 to the n, 2 to the 1 is 2. And let's assign priority. This carbon is attached to a O, so that's the 1. Hydrogen is 4. On this side, is this chiral carbon? Oh, actually, no, that's the point, right? The answer is 2 to the 0 is no chiral carbon, right? Why? Even though, as I said, this has in and out, that's not an automatic criteria for chirality. Why? Because the groups are exactly the same on either side. This looks exactly like this. So that means this carbon is not attached to 4 different groups, so it does not follow the rule of chirality. So there is really no chiral carbon, right? 2 to the 0 is 1. So that's not necessarily an answer we're looking for. But why did I actually show this is to show you that if you give one, you have to assign the other one the opposite. Whether it's in given, then you opposite out is hydrogen. If out is given, then the in is hydrogen. Okay, but in this case, there's no chirality because the groups are exactly the same on each side. Let's go to this one. Again, what is important is you can assign priority. This is not easy because your lowest priority group, this is the carbon, which contains hydrogen, a bromine, a fluorine, and then this is attached to CH2 and CH3. So these two are not chiral, right? Because this is CH2, CH3, that's not chiral. This carbon is chiral, but we cannot assign priority right away because if you think about it, this is 1, right? And this is 2, this is 3, and this is 4. Your lowest priority group, which is 4, must be either in the front or back position, right? So we cannot assign R or S yet, right? So how can we go about doing to actually determine R or S for this one? We have to modify something and then come back and conclusively determine that. So what I'm going to do is redraw this, but either switch either one in the in or the out for this hydrogen. So I'm going to bring maybe the fluorine here. Switch places, switch the fluorine for the hydrogen and the hydrogen for the fluorine, and then leave the Br there. Switch one, either switch for the in or switch for the out. Doesn't matter which one. Now go back and assign priority. This carbon is attached, first point of contact, Br is big, second fluorine is big. This is attached to carbon, which is smaller than fluorine, so that's 3, and hydrogen's 4. Now connect the 1, 2, 3s. So that's clockwise, and hydrogen, the fourth group is in the back position, so clockwise back is R. So keep in mind, this is not the structure we're trying to determine R and S for. We had to make the modification so we can determine this is R. Because we flipped, if this were to be R, this should have been S. So you basically flip it. Because we had to flip the atoms to make the accommodation to arrive at this, because you want your low priority group to be either in the lowest priority group to be either in the in the in position or the out position. I switched for the out, you could have switched for the in. It wouldn't have made any difference. So if this was R, what we had started with should have been S. Does that make sense? Okay, so this is the last one. I'm going to redraw this because I think that little bit of overlap was there. Now we have not really learned ring structures yet, and I don't think you have to know a lot more at this point, but this is good enough. You see, in this case, again, this is the only problem where you have to flip. In most cases, you do not have to. Now, again, this is not a chiral carbon because anytime you have a bend, that's a CH2, right? So that is not chiral, this is not chiral, this is not chiral, this is not chiral. This is the only one that's chiral, that's containing a Cl, a hydrogen. So this is number 1 priority. This is 4. Assigning 2 and 3 is difficult for a lot of people. If you think about it, this carbon is attached to this carbon, and this is both attached to 2 hydrogens, so they're the same. So we move forward. This carbon is attached to carbon, so is this one, right? But this is only attached to a hydrogen, this is attached to oxygen. So this side is bigger, so we put the 2 on this side and 3 on this side. Does that make sense? I purposefully chose 4 different compounds. I can address all of the concept in one maybe rather long video than making 20 different videos on the same topic. So this is 1, 2, 3, right? That's clockwise, right? And the lowest priority group 4 is in the back position, so that's R. Let's do the same for this one. This is 1 because this carbon is attached to high priority 1. This is 4. Again, on this side there's C, and then if you keep moving, this will be, let's do it here. Okay, if you want, we do it here. 1, 4, right? With respect to this carbon, this is the same. This is where things are different. This is also carbon, this is also carbon, but this is only attached to hydrogen. This is attached to Cl. So this will be 2, this will be 4. So if you connect the dots, it's 1, 2, sorry, this will be 3. 1, 2, 3, 4, right? So this is counterclockwise, and the lowest priority group is in the front position, so counterclockwise front is R, right? So R and R. So how many stereoisomers does this have? We only have 2 chiral carbons, so 2 to the 2 is 4, right? That's how you do it. This one had only 1 chiral carbon, so it's 2 to the 1 is just 2. All right. Now, this is for you to practice. Okay. Now, it's really important. Don't worry about the next video after this. Okay. If you don't understand what's presented here, and if you cannot do these 3, then there's a chance that you didn't understand R and S. We need to focus on get you understand this stuff. Okay. So go back. Watch this video. It's not that difficult. may look crowded now, but when you actually watch it as a video, only one thing comes at a time. So watch it, and then that'll be the end of R and S, and then practice these problems. All right, I'll see you back with key idea videos.